Good morning, anybody who's on the call now. We have, of course, two-way chatting, and you'll be able to let us know if you have questions. Let me start with an introduction here. I am Wayne Burdick, N6KR with Elecraft. I'm Elecraft's Chief Technology Officer and one of the co-founders of the company. And I have with me Doug Nathan, KC6PLN. Doug is my co-host, and he will be fielding your questions and engaging you in some discussion as we go through the presentation. So Doug, are you seeing some visitors to our video at this point?
Happily, I have 41 participants in the broadcast.
Okay, great. And can you ask for a volunteer to raise their hand and let them know that they're hearing the audio and seeing the video okay?
Anyone who'd like to post a statement and question and answer would be most appreciated. Thank you kindly.
Well, so coincidentally, I just saw a bubble pop up and say that a number of participants virtually raised their hands using the feature in Zoom. So thank you very much for that, folks. And just a reminder, this is a talk about the KX line, and specifically I'm going to be discussing some design process that Elecraft uses with all of our new products when they are first conceived. Of course, they all start as a crazy idea, and the KX2 is a good example of that. And then we'll also be talking about, excuse me, the KX3, which actually came before the KX2. And we'll do a little brief mention of some KX line history in general to set the stage for that. And forgive me, too early in the morning. So then we'll look at the 3D model of the KX2 and build the model up one layer at a time so you can see how the boards, the other assemblies all fit together, how the accessories plug into the KX2 internally and externally. And you'll get an idea of why we use 3D modeling. It's not important just because the model informs subsequent mechanical and electrical design. It's also that it's an envisioning tool. It really lets you feel like you've got the radio in your hand and you can see what it looks like and imagine holding it. And that motivates not just the design process, but it also motivates people like me who are going to be involved in the design and use, and in giving ourselves a bit of reinforcement that when we have the finished product in hand, our customers are going to like it just as much as we do. And I've said it before that it's kind of like Field of Dreams. You know, if we design it, then hopefully people will like it just as much as we do, and will be interested in having one of their own. That motivates all of our product manufacturing and invention. So let me go ahead and switch now to the to the 3D model. So I'm going to share my screen, stand by. Okay, so Doug, do we have the 3D model showing now?
It's lovely. It sure is showing.
Okay. All right. So the tool that I'm using is a very powerful and pretty simple to use modeling tool that I've also used for some architectural projects around the house. And I started using it for radio design something like 10 years ago. And so as you can see, we have a three-dimensional model of the KX2, and it's all put together here. I've got it on a simulated tabletop. The model lets you put textures on things. And when I zoom out a bit, you'll see that we also have the KX2 attached to an AX1 antenna, and it's telescoped down right now so that you can see the whole thing. And the KX2 is also connected to the antenna through a right angle B&C jack. And the B&C jack in turn is attached to this thing that we call the bipod. This is the KX-BT2 bipod. And if anybody's ever shot a rifle in a range where you're lying on your stomach while you're doing it, then you may have used a bipod yourself. A bipod is often used to hold a rifle. Sometimes a bipod is used to hold a camera. In this case, it's holding up the antenna so that if you are operating on a table, the antenna doesn't flop over. And it'll handle a moderate breeze. If your breeze gets too stiff, then you need to find a way to anchor the legs of the bipod directly to your picnic table, etc. Of course, this is just one way to use the whip. I will go ahead and show an alternative method of using the whip here. I'm going to turn off the bipod. And so now we've got the same antenna, but now we've attached it to the radio, and we can now use the radio like an HT. And you may have seen pictures of a couple of us using the KX2 or the KX3 in this HT mode. That's the reason why the antenna connector is located where it is. And let me zoom in a little bit here so you can just see some more of the detail before I start dissecting the radio bit by bit. In a one of a kind, a first of its kind event in history is laboratory dissection of a KX2. Fortunately, it's only virtual. We're not going to do a real teardown here. Okay, Doug, how are we doing in terms of people being able to comment on what they're seeing? Are you seeing any questions at this point?
We have 50 participants, and I'd encourage them to post in the Q&A section if you have any questions for Wayne or about the KX2 or any other Elecraft product that we can help you with.
Excellent. Okay, now you may have noticed that I had shadows turned on. That's one nice feature of the 3D modeling tool, is that it allows you to envision things as they would look in real life. And so, for example, I've got shadows turned off now so that we can more clearly see some of the textures in the model. And here, for example, is a rendition of the label that's internal to the AX1 antenna, which just shows you what band you're on with this switch right here. And you notice the switch is recessed into this plexiglass tube. So the tube protects the antenna. The switch has just a tiny hole for accessing it. And so it's more or less weather resistant, we'll say. Okay, so enough of a focus on the antenna for now. That is the AX1 antenna. And if you're curious about the AX1, you can check out the data brochure for the AX1 product line. Just go down below our exhibit booth on the VFairs website, and you'll find a row of buttons down there. And one of them, way down at the bottom, if you scroll all the way up, you'll see a tab you can click on for documentation. And in that area, you'll find brochures for all of our products, including the AX line. And Doug, you might want to check my work there. I'm pretty sure that the AX line document is in there, but I'm not sure that I actually saw it myself. And well, actually, I'll make one more point about the AX1 right now, which is that the AX1 is nominally a dual band whip, as you can tell from the switch. We can select 20 or 17 meters. But one of the reasons why the whip works really well with Elecraft's radios is that our radios have a built-in automatic antenna tuner. And anybody who's tried to use one of these electrically short whips themselves has probably noticed that the SWR can vary all over the place depending on the terrain that you're walking in. And there are many factors that affect the actual impedance of the whip. So the SWR will vary all over the place. So the beauty of the automatic antenna tuner is that you can be walking along carrying the radio, using the whip, hit the auto tune button, and have it compensate for all of those factors and match the antenna to the whip optimally. Most other radios don't have automatic antenna tuners internally, so it renders that type of operation very inefficient in transmit mode. You might have an SWR of 10:1 at a certain point in the band if you're over a particularly unusual kind of terrain. So the auto tuner compensates for all of those effects. Okay, so now let's turn the antenna off and focus on the radio itself. Just take a quick look at the front panel here. And it may be hard to tell from the image, so I'll tell you what the actual dimensions of the radio are. I used to have them memorized, but now I'm going to pull a ruler out. So the width of the radio is 5.7 inches. The height, as you're seeing it here, is 2.8, and the thickness is about 1.5. So this is a very small radio. And just to put it in the context of something that you might recognize, with these dimensions and a weight of only 13 ounces, it's approximately half the size of a KX3. It's half the size of an FT817, and it's about 1/3 the size and weight of an IC705, just to give you some examples. So this is truly a small radio, and you'll see me holding it in my hand later in the presentation so that you can get an idea of what it looks like in actual use. But what it feels like is pretty much a medium-sized HT. So if you ever used a handy talkie, then you know what a KX2 is going to feel like in your hand. And it really is the world's smallest all-band, all-mode, handheld HF station. And certainly the only one that also includes both internal battery and an auto tuner. Has a built-in mic too. And I will show you where the mic is. It's not real obvious when you first look at it. The fact of the radio's small size was not lost on Special Forces Command for the US military. We were contacted a few years ago when we first came out with the radio by a Special Forces commander who had realized that this was about 1/20th of the weight of the man packs that they were carrying around, and yet it put out almost the same amount of power, 10 watts. It's only 3 dB down from the 20 watts of their man packs. So it saved them so much weight in their backpacks, they were able to carry KX2s as a backup HF rig for all of their deployments. And they use them in the swamps of Louisiana. They use them in sand dunes in Iraq. They use them in the jungles of South America. They use them for NVIS communications, for secure data links, etc. They even jumped out of helicopters carrying these things. And the commander told me that the KX2 had survived all the jumps, and one of them he almost didn't survive. So we're really proud of the radio's small size and what it facilitates in terms of use by both our customers who are out wandering the world looking for the next great operating space, and also even for our Special Forces teams. So I have no idea how many of them are actually in use for Special Forces, but we were quite gratified to know that the radio was rugged enough for that kind of use. So I'm going to now adjust the viewing angle a little bit here, make it just a little more square so that you'll see things without a parallax problem. And some of you who have not had the pleasure of operating CW might not recognize what this thing is here on the front. This device here is one of our keyer paddles. This is a KXPD2. And you might notice that that it appears to be made out of metal and plastic, and you would be correct. The paddles and the contacts, as well as these thumb screws, are made out of aluminum. The thumb screws are steel, the paddles are aluminum. The housing of the paddle is actually made of polycarbonate, also known as Lexan. And so it's transparent. And I'll show you my personal KX2 that I've been taking to the field for 3 years now, which also has a KXPD2 mounted on it. And you'll be able to see what this transparent plastic actually looks like in real life. But this model that you're seeing here is actually used to 3D print the keyer paddle housing. And so again, you know, when you're trying to make the world's smallest HF rig, you really have to think about all the ways you can save space. And so this keyer paddle was designed to be as small as possible, consistent with still providing basic, good keyer functionality. So let me turn it around and you can now see the backside. And you're probably wondering what this funky black thing is here, and I'll explain that in just a second. But as you can see, the KXPD2 is made up of a very small circuit board that has the standoffs connected to it with screws. And then it's nestled inside the plastic housing. And the paddles are captivated by the Lexan housing. And then we have contact wires that go from these little tiny solder lugs to the PC board. So that's how a KXPD2 works. This long skinny thing here with curve in it is actually an Allen wrench. The KXPD2's housing was printed with a hole right here that the Allen wrench fits inside of with a snug friction fit. So when you're out in the field, if you ever find the need to adjust your keyer paddle spacing, then you got your Allen wrench right there instead of having to search your bag for one.
Wayne, at 16 minutes, we have a question from the audience.
Excellent. I was just going to ask, okay, what's the question?
David Dusty wonders about the KX2s that were used by Special Forces. Were they in any way weatherproofed as far as we know?
No, they were not. Most of the time, yeah. In fact, the commander made a point of telling me that they did not, they were in some very harsh environments and they never had a problem with the KX2s just as designed. I have thought about ways to weatherproof the KX2 somewhat. One example would be to design a thin rubber membrane that could overlay the switches on the interior, the switches and the knob shafts, and that would go a long ways towards additional weatherproofing. And I have thought about doing that. Just haven't had time lately. I've been a little busy with the K4. But that's an excellent question, and using a membrane in that way would not add to the size, weight, or cost of the product significantly. So, if the gentleman has a follow-up question later on, or suggestions, things that he's thinking about for weatherproofing, have him feel free to bring that up later on. Any other questions while I'm at it?
Not at the moment, but lots of good comments about the presentation, high quality and thoughtful.
Okay, great. I'm glad everybody's able to hear me. When the night before a major presentation, the universe doesn't guarantee you're going to sleep really well. And I was up at 3 o'clock and then back to bed at 3:30. So hopefully the frog in my throat is the only side effect of that brief loss of sleep last night. Okay, so let's now turn off all the layers in the model. And to do that with any luck, I can simply do that. Okay, and now we're going to go back and build the KX2 from the ground up. And as the principal engineer on this project, the first thing that I think about with a radio, given my training in ergonomics, user interface design, is I think about what the front panel is going to look like to the user. And that in turn determines what's on the front panel circuit board. So as you can see, I've actually pulled the model of the circuit board itself here into my 3D model. And that allows me to make sure that when our PC board engineer is designing the board, he and I will coordinate carefully on the locations of all of the components. So we go to the trouble to model everything that's relevant to positioning. So for example, here's an LED. This happens to be the RIT offset LED. And we've got a little spacer that's used to keep the LED in the proper position with respect to the front panel. And then we have shaft encoders. And I didn't go to the trouble to model those in any high level of detail. The important thing is that they're modeled enough so that we understand what all the obstacles are for the board. All right, now let's add some more things to this front panel board. Let's flip around and look at the back first. So here's the other side. As you can see, we've got places for the microcontroller, the digital signal processor. We've got a display controller right here, and I'll talk more about the display later. And this thing right here, this is actually the connector for the keyer paddle. It's a surface mount connector. You can see that it's a surface mount connector because it has pins that extend backwards onto a group of 4 pads that it then gets soldered to. And you see all these little red circles? What the heck? You know, those don't look like components on a circuit board. Those are actually design rule check violations that were still in effect at the time when I imported the circuit board. And you'll see them in places where we have push button switches. So let me go ahead and describe how these switches work on the KX2. If you've seen a KX2, you know that it has a number of switches, about a dozen rubber switches, and I will add those to the model. So again, the tooling that was used to create our switch array was actually derived directly from this 3D model. And so the switches have to be designed in such a way that they have some webbing between them and the little bosses that separate them at the proper distance from the front panel. So you see this moat around each switch, and that little moat is the webbing. And then between each of the rubber switches, which acts like a plunger, and the circuit board, you have, as part of the switch matrix, I can't show it here, but there's something called a polydome. Think of it as a clicker. You've seen little clickers that you hold, and when you snap it, it makes a clicking sound. Every one of the switches has a little polydome clicker. And when you press the switch, what you're really doing is inverting the polydome so that it snaps into position against the circuit board and makes contact with the circuit board traces to effect a switch closure. So that's how these switches work. And it has a cost advantage, obviously, in that the clickers are built right into the switches. The webbing is built into the switch array. I'll mention that the K4 transceiver takes this concept to a different level, where the K4's front panel board itself actually has tactile switches of the type used on keyboards. So we have extremely high performance, long life push button switches for every switch on the K4. And then the rubber switch array then lays on top of that. And so when you're pushing the rubber switch on a K4, you're not clicking a polydome, you're actually pushing a switch, meaning the switch is an extension of your fingertip. So the switches on the K4 kind of are at the next level of expense to us as a company. But for when you're doing, most products of this type are not designed that way. Most handheld small products are designed using high reliability carbon polydomes as the switch technology, because they're so small, they're so lightweight, it's appropriate for portable equipment. Now, the switches themselves actually act like an environmental barrier for the polydomes. And so we almost never see a bad switch in the field with any of our products that use these rubber switches. In fact, this is the same way that we designed the K3, K3S, KX2, and the KX3, PX3, P3. All of those products use these rubberized switches that are custom made for the application. K4 just takes it to one additional level above that. Okay, now I'm...
Question from the audience, man.
Yeah, sure. Go ahead.
Joseph Schumann wonders if we have any plans towards having a Bluetooth connectivity aspect in order to interface with hearing aids in particular.
The short answer is not at this time. First of all, as you'll see, the KX2 and KX3 are already, the density of their assemblies is already so tight that there really isn't room to add Bluetooth hardware to it. But the longer answer, and really a major consideration, is that Bluetooth incurs a propagation delay through its signal path, and so it's a little like, especially for CW, it's almost impossible to do QSK CW through a Bluetooth interface because it has on the order of a couple hundred milliseconds of delay through the path. It's okay for sideband, and it doesn't matter for data modes, but for CW, which is a seminal feature of all of our radios, the propagation delay caused by Bluetooth is just too excessive. That said, if we do future radios, future products, we will certainly take that into account. I hadn't thought of Bluetooth as a way of improving accessibility of the design. That's an excellent idea. I guess the question is, can you get Bluetooth repeaters in effect that then have a headphone jack that then plugs into the radio? If the gentleman would like to comment on that, that's fine, but I'm guessing that's the way he uses existing products that have 1/8" or 1/4" headphone jacks, is with some sort of adapter that then communicates to his hearing aids directly with Bluetooth. Is that correct?
He describes it as a box larger than the KX2, independent between to do just that purpose.
Ah, okay. Well, that sounds like a product opportunity. So feel free to email us with the details of that box, and maybe we'll create our own much simpler appliance for converting from all of our radios, which have the 1/8" headphone jacks, to a Bluetooth interface that can then go to wireless hearing aids. That would make an excellent product opportunity, partly because it would be retrofittable and usable with all of our gear. So I'm very interested in that, and thanks for the question.
We'd welcome any follow-up emails to come to this email address, support@elecraft.com, support@elecraft.com.
You know, Doug, you're really good at this. It's like, I feel like Johnny Carson and you're Ed McMahon. So I imagine some of our customers are old enough to remember that duo. So keep up the good work there, Doug. Okay, so I promised earlier that I would show you where the built-in microphone is on the KX2. And so I'm going to quickly turn on the front panel, and you'll see that there's a tiny hole right here. This little hole, which happens to be in just the right place for when you're holding the radio and using it like an HT. That hole is associated with this little chimney. Now you see how we were able to use the rubber switch array, which is a custom fabricated piece. We're able to use that for multiple purposes. So in this case, it's a little audio cavity that protects the microphone, and the microphone is this surface mount part, which is actually only 1/8" square. And so it's recessed inside its little acoustic chimney, and that provides a kind of audio waveguide for the signal to get through your voice to get through the hole and to the microphone. And that mic works really, really well. Of course, the KX3 and KX2 both work with our MH3 microphone, which you can plug in on the left side. But the built-in mic comes in really handy if you're in the field and you're using the thing handheld. All right, let's add some more parts to this front panel.
This is a good time to ask a design question from our customers.
Yeah, sure, go ahead.
Dave Kearns, GM0HVS, asks, how far down the line does this design work happen compared to circuit design and PC board design?
Okay, well, that's a great question. So the usual process is, first, there's a crazy idea. In the case of the KX2, the crazy idea was, can we actually shrink the KX3 by 50%? So then what I do is, having decided that we really want to know the answer to that question, I will then go and do the 3D modeling of the overall package. And once I have convinced myself that there's room in the target package size for all the controls that we need, the display, the accessories, the battery, once I believe that there's proof of concept from a packaging standpoint, then we get the printed circuit board designers involved. In this case, we had a couple of designers, one who did this board and one who did the RF board, and I'll show you that in a minute. And so the trick then is that we have an iterative process where the PC board designers work very closely with me to make sure that all of the pieces fit. And believe me, we're measuring down to the thousandth of an inch when we're making design decisions about where to place things. I'll show you an example of that. I'm going to go ahead and put the LCD on here. So those of you who've used any Elecraft products in the past will recognize this LCD. This is the LCD that we designed, or I personally designed the segments for this LCD back in 2003 when we first started work on the on the K3 transceiver. It's the very same display, and it's also the same display that's used on the KX3 and the K3S. So the beauty of this display is that it's segmented, and it has a multiplex rate of only 4:1. Now what that means, you have to compare that to the multiplex rates of much larger LCDs, which are typically 80:1 or 200:1, something like that. And the beauty of a low multiplex rate for an LCD is that you can see this LCD in the brightest sunlight. It's what we call a transflective LCD. Transflective means it can act transparently for purposes of sunlight bouncing off the mirrored surface on the background, but it can also act transparently, which means when you're turning the backlight on, the backlight shines through the display and lights it up at night. So you have incredibly good visibility of this display under any lighting conditions. And when I said that the multiplex rate was 4:1, what that corresponds to is that the LCD has 240 segments, but it has 4 backplanes and 60 segment pins. And you can see these pins arrayed around the display. And when we designed the display, we did it in conjunction with designing the radio so that the pins would not interfere with anything. So let's just take a close look at just how close we got. So if you look right here at this red LED, you'll notice that the pads, these gold colored rectangular pads for the LCD, are actually 2 different sizes. So we used the larger pads everywhere we could, but when we got close to this red LED, we narrowed the pad size down to give us more room for other components. So, so the general design process is crazy idea, and then we do a little bit of design thinking. We throw it out to some potential customers as a focus group just to make sure the crazy idea was a good one. Then I go off and do some tentative packaging design, and then we get the PC board designers involved, and we also have to design subsequent assemblies like the LCD and the switch array. And we generate technical, production documentation directly from the model. Actually, let me show you one other thing really quick. Are you still seeing the same screen, or are you now seeing the PDF of the LCD?
Same screen, a frozen image.
Okay, so hold on a second. I have to temporarily stop sharing my screen, and now I'm going to go to I'm going to start sharing with a different file, and you should now be looking at a bunch of red lines. Are you with me there, Doug?
Indeed.
Okay, so what you're looking at now is the original design documentation for the LCD itself. So every part of the system goes through a design process. And in the case of the liquid crystal display, we had to go from the crazy idea to 240 segments. So we used up quite a few segments for what you see here, which is the VFO-A 7-segment display. And then this is the VFO-B 13-segment display because it's alphanumeric. And you can see the mode indicators, the S meter, the segments for the DSP bar graphic, etc. And I will tell you that toward the end of the design process for this LCD, I had run out of segments. My original intent was to use 14 segments for each of these LCD elements for VFO-B. And the problem is I ran out of segments, and so I had to create an alphanumeric display that used only 13 segments, which was a neat trick. I'm going to see if I can zoom in a little bit.
Wayne, as we pass the 35-minute mark, I have 2 live questions and then a follow-up question from a KX3 operator looking forward to a moment of your time. Are you ready?
Yeah, go ahead.
Tim, November 9, Papa Uniform Zulu, asks, it would be great to have an option for the mic to have a push-to-talk function versus just toggling it on and off.
That's an observation that several people have made. I believe one of the third-party vendors in Brazil has actually made himself a PTT switch that he uses. So I would look up, I can't remember his call sign, but I bet somebody else can come up with it. He
Is
has
this Alex Mike?
Yeah, Alex Mike, yes. And Alex actually has rolled his own PTT switch that fits on the side of the radio, and he uses it with his loop antenna. So that has been done. So if you're anxious to get a PTT switch, that's a way to do it. The other thing you can do is use Vox. Maybe not everybody knows that the KX2 includes most of the same single sideband and voice features of the K3. And one of those is Vox. So you can set the Vox level and the anti-Vox level. And when you're using the radio handheld, Vox works quite well, unless it's really noisy. So it's just a menu entry in the KX2 and KX3. So I think I'll just go ahead and wrap up the discussion about the LCD by saying that you always have to make compromises because the number of segments is limited by the display controller and the format. But the net result is we get a fantastic display in terms of readability in bright sunlight. And that, of course, is of critical importance to to products that are going to be handheld and used outdoors. All right. In fact, let me just mention that that of the other radios in the class of the KX2 and KX3, meaning all band, all mode portables, there is one new one that's coming on the market, and it does have a full color LCD, and I guarantee you, you will not be able to see it in sunlight. And if you were to compare this display to anybody's, like color LCD, you're going to discover that the KX2's display is completely readable under any lighting conditions, whereas you're going to struggle and be looking for a tree to hide under if you have a color LCD. That's enough said on that point. Okay, Doug, did you have some other question you want to sneak in before I continue?
Sure do. Andrew Hall, Kilo 2 Oscar Oscar, asks about using iambic pedals. He prefers bug pedals. Do we have any operating mode in the firmware with KX2s for operating bug?
Not at present, but somebody asked that question yesterday, and it's definitely now on the wish list for the KX line. I can't say when it might happen, but it's certainly possible for us to support bug operation in the future. Any others before I go on?
Battery in KX3, I'm keeping that in the wings.
Okay, yeah, when we get to the KX3, we can talk about that. All right, so we've now put together most of the components on the KX2's front panel. Just for completeness sake, I'm going to go ahead and add in the knobs. And again, the knobs have to be designed from scratch, and these do look very much like the final knobs that we had custom manufactured for us. And somebody, multiple people have said, well, why not use a heavy metal knob for the VFO? And the reason is that even though these encoders that we used are long life shaft encoders, they are incremental contacting style encoders, which means they have resistive contacts. And if you put a heavy knob on an incremental contacting shaft encoder, you'll wear it out about 5 times faster than if you simply use the plastic knob that's supplied with the radio. And the main reason people like the heavy knobs is because they come with a dimple and that they coast for a while. But if you ever get a chance to pick up a KX2 and try it, all you have to do is lightly run your finger along the rim, and it will spin very freely. Just to imagine that you're making a tone on the rim of a wine glass for much the same reason. And I'll leave it to the reader to extract a metaphor out of that that's appropriate. But that's what you do, is you're running your finger around the rim of your wine glass, and that tunes the VFO quite nicely with the plastic knob. Of course, the KX2 also has built-in scanning. You can set up VFO A and B for your target begin and end points and let the radio do the work of hunting for signals. That's a feature that, again, we borrowed from the K3. All right, so we've got the knobs on. Now let's go around to the other side and add in the RF board. And the RF board, you'll notice, is an earlier model that doesn't include all the circuitry, but that's useful here because it shows us, it's easier to see some of the details. At one end, we have all the connectors. At the other end, we got the RF power hardware, or circuitry. And that's important. When you're designing a radio like this, you don't want to put the antenna jack right next to the microcontroller or right next to the audio circuitry. You want to keep the RF and audio stuff separate and keep the microcontroller down near the audio stuff. So that's what we do with all of our products. You will see some other radios on the market where the antenna is right next to a USB connector, for example. That is not a good idea. Okay, so you see that this radio has two DC barrel connectors. Now, those who've used any of our products or of any of the things that I designed in a previous life for Wilderness Radio or the NorCal QRP Club will recognize these as 2.1 millimeter DC barrel jacks. That's where you plug in your power supply. Why are there two of them? Well, that's because the battery in the KX2, which also was custom fabricated for us, this lithium-ion battery plugs into the internal DC barrel connector on the circuit board, or you can take the battery outside and plug it into the external DC jack. That also makes it very easy to recharge the battery. You just plug it into the charger outside the radio. And because we use diodes to wire or the internal and external power supplies, it means you can have a battery plugged inside the radio and then have a second battery or a solar panel or some other supply connected to the external DC barrel jack. And the radio will simply operate from whichever one has the higher voltage at a given time. In fact, if you were running from a smaller solar panel, given how little current drain the KX2 has, only 150 milliamps, which by the way is about 1/5 of the current drain of the new radio whose name will not be spoken, that also has a much smaller battery than the KX2. So the KX2 has much longer battery life than competing radios, and it draws way less current, which means a lot more operating time. And it also means that you can run the KX2 from as little as 8 volts from a solar panel. And the receiver may get powered by your solar panel, and then let's say that's a pretty wimpy small solar panel. When you transmit, if you got the battery inside the radio, it'll draw power from the battery when you're transmitting. So you kind of get the best of both worlds in terms of maximizing the utility of your power sources and being able to use a really small solar panel. And you can operate for weeks this way on a backpacking trip with just one tiny solar panel. Okay, so we've got the battery plugged in. We have the RF hardware on this end. I'm going to go ahead and add in the auto tuner that I mentioned. So here is the auto tuner circuit board, also an early model. I'm not showing all of the hardware that supports the board. And I will go ahead and add in now the speaker. The speaker isn't going to show up here because it's part of a different model, which is the bottom cover. So let's go ahead and put the bottom cover on. And that's where the speaker is. And I'll show you another feature of the 3D modeling package here, which is we can change to monochrome mode. And monochrome mode is often used by designers when they are refining the positions of objects so that they don't have to look at the texture on everything all at once. So as you can see, some of the geometry of the part is much easier to explore in monochrome mode. So let's go back to full shaded with textures. You know what, let me show you one other viewing mode, which is of critical importance when you're like really trying to maximize the efficiency of your space utilization. This is what's called X-ray mode for obvious reasons. And you'll notice that we can see right through the battery to the 18650 cells. We can see the circuit board. More importantly, we can see the relationships between the top and bottom boards, how they plug together. we can need to see these conical rat tails that come off of the switch matrix. So in terms of getting your space utilization right, being able to see through the board for obstructions is what you need to be able to do. So as you can see, this modeling package does an excellent job with X-ray mode.
I wonder, Wayne.
Yeah, go ahead.
And Frank Qualls also wonders if there's enough room in the KX2 to perhaps shoehorn in a high precision GPS module for geolocation, as a portable radio would love to be able to do, and for high precision timing for data modes.
Well, the answer to the first question is yes, we could shoehorn in GPS. It would increase the cost of the radio by probably somewhere between $20 and $30. And we elected not to do that because typically people who are using their KX2 in the field also have along with them an iPhone that they're using or an Android phone that they're using to monitor their location, to do their mapping, to do logging of their trip journal. So it didn't seem like the added cost of the GPS was worth it, for all of our users to incur that cost. That said, in the future, if we have other radios of this type, we'll probably make GPS an option, maybe make Bluetooth also an option, but we will not be retrofitting that to the KX2. And then the other question had to do with locating, I think. Sorry, there was a second part to that question. Why don't you remind me what that was?
Frank went on to ask about high precision timing availability through a GPS type signal for data modes.
For data modes. So the data modes that require accurate timing include FT8, FT4, JS9 call, things like that. Unfortunately, those data modes also require an external computer. And the algorithms used are there's a lot of intense processing activity that's required. So even if we were to try and put a processor inside the KX2 that could handle something like FT8 mode natively, and therefore require the GPS chip, what that would do is take the current drain from 150 milliamps in receive mode to something like an amp. And increasing the current drain by a factor of 6 is not consistent with the design goals for the radio. So this is certainly something, again, that we'll look at in the future, is how much of the division of labor should there be between the radio and the computer. Given that you almost always need a laptop or netbook computer with you in order to adequately use the user interface for FT8 and similar modes, you got that computer anyway. That's where the work really should be done for both demodulation and display. It's just a better segmentation of labor. So that's why there's no need for that kind of timing accuracy on the radio itself. Now we do have something that we call the KXIO2 option, and that is a board that gives you a real-time clock for the KX2. And in fact, we're displaying the UTC time on the VFOB display here. Okay, so let me go ahead and just quickly turn on the rest of the panels. And Doug, do we have till 10 or do we have till somewhat after 10?
I have until 10:30 for the end of your demo.
Okay, so if I haven't put people to sleep yet, stick with us and we'll actually do some physical demonstration in addition to the virtual demonstration here. All right, I'm going to go ahead and turn on some more of the features here, and I'll start with the left side panel. So this panel is actually fabricated with some machining, and the reason for that is kind of hard to see in the shaded version. So I'm going to go ahead and go into monochrome mode for this, and you'll see that we machine recesses around these short depth PC board plugs. And this is all in the spirit of keeping the radio as small as possible, but still working with a variety of 1/8" headphone plugs. If we hadn't provided this recess, then it would only work with the incredibly skinny style of 1/8" plugs that you have with things like iPhone headsets. But because we give you this recess, it means it'll work with legacy adapters like 1/8" to 1/4" headphone adapters, etc. So another thing that's machined into the left side panel is an unpainted surface area here, so that you get good contact with your with the thumb nuts that are on the bottom panel. So let's turn the bottom panel on. There is the thumb nut, and there are actually two of them, one on this end and one on this end. And these thumb nuts serve a dual purpose. One is to hold the bottom cover onto the radio and provide quick access to the battery. And the other purpose is that either one of them can be used as a ground location for a ground wire. And again, the intent with all of our portable products is to integrate as much of as many of the accessories and affordances that you need into the radio itself as we possibly can. Let me give you another example of that. You'll notice there's a little hole down here. This hole, and you'll see that it's actually not a hole. It's a circle that indicates where a hole should be. So I'm going to just take that opportunity to see if I can clone this. And now I'm going to actually make it into a hole. And so what I did just there was I extruded the piece and put a hole right through the metal. That's how you make these models. You draw geometric shapes and then you extrude them in various directions. If I someday wanted to add a new feature to the radio that happened to be rectangular, I just do it like that. I can adjust the size. I can very quickly do things like add an inset border. So there I've made something that looks just a little more interesting. And you can also take three-dimensional shapes and merge them together and either save the combination, the union of the pieces, or you can save the intersection of the pieces. So it's fascinating. 3D modeling is really a fun thing to do. I started learning it when I was about 50. So anybody can do it if I can do it. Okay, so we now have a hole there, and the purpose of that hole is to plug in a ground wire. So let's go ahead and plug in a ground wire.
Wayne, regarding the...
There it is. That is the ground wire. Hang on a second, just a second. So I just want to mention that this ground wire is representative, and you notice that I also attached a BNC to banana adapter or binding post adapter on the other end, and I'll put the right side panel on so you can see that. So this is the other way to use the radio, is to just connect a binding post adapter to it, and then you lay one wire on the ground, throw another one in a tree. But if you're operating handheld with the whip, then you probably want to use the HT style whip here and then use a trailing ground wire. And just for those who have never done handheld HF operation with the radio, you absolutely positively cannot do it with just the whip, because that would mean that your body capacitance to ground was the only thing providing a return path. You need a counterpoise wire, or your transmit signal will be something like 20 dB weaker. So we provide a place to plug a mini banana plug in right here in this corner, and I think I even modeled the banana plug. Yes, there it is. Okay, what was the question, Doug?
Basically, what modeling system are you using, CAD/CAM machinery-wise?
Yeah, that will cost you an extra $5. No, okay, so this is called SketchUp, SketchUp. And SketchUp, the basic version of SketchUp is actually free. It's called SketchUp Make. Just go to sketchup.com. You can download it. It'll run on Windows or Macs. I don't know if it runs on Linux, probably. And watch the videos, the training videos, and then yeah, you can design your own second-story house addition, or a doghouse, or a keyer paddle, or whatever you need to design. And during the pandemic, you know, do it yourself is definitely the rule, not the exception these days. Yeah, I highly encourage anybody who thinks three-dimensionally to get their hands on a 3D modeling package. And this is SketchUp is just an outstanding example of a 3D modeling package. So let me, actually, let me quickly segue into one other thing. I'm gonna share a different application here. I'm gonna go to Firefox and open up a window into SketchUp's 3D modeling library. Are you seeing the model library there, Doug?
I see that it's 6:55 p.m. in Paris with a very cool clock from time.is.
Okay, so one of the idiosyncrasies of Zoom is that you got to start and stop sharing again if you want to change screens. Don't ask me why. All right, here we go. So now I assume you're seeing the SketchUp model library.
That's true.
Okay, so here is, you can see just a range of things that people have modeled. Let's say that I think somebody in the world has modeled a BNC jack so that I don't have to do it myself. Well, by gosh, somebody has modeled a BNC jack, and there it is. And I'm going to zoom in on the screen here so you can see it better. Is that making it zoom for the viewers?
Yes, it is.
Okay, so here is a model of a female BNC jack, and it's not. Oh, there we go. So once you pull up the SketchUp model, I'm going to reset the zoom here. You can then download it and put it directly in your own model. And some of them allow you to spin them around and look at them right on screen, etc. So the model library has everything from BNC connectors to 747 jumbo jet already modeled. Here is a 747. And believe me, when you open that model up, it's going to have everything right down to the USB plugs where you plug in your laptop at your seat in your aircraft. So most of the things that you can imagine have already been modeled if they are useful to multiple people. You can find plants and other landscaping objects if you want to design your own landscaping. I believe at one point that the entire Hogwarts castle was modeled. Oh yeah. So how many times have people modeled the Hogwarts castle? Looks like about 300 people have modeled their idea of the Hogwarts castle. So anybody who's familiar with Harry Potter will know what that is. The other thing you can do with SketchUp is position your model in the real world using Google Maps. It will actually show your model in the place you modeled it. So if you're modeling a home edition and you want to know what it looks like from Google Street View, you can drop it into Google Maps and it'll show you what your house is going to look like with the model on top of it.
Wayne, it seems a delightful tool. I wonder, has anybody ever designed a pan adapter for the KX2 in that tool or anywhere else?
Nobody has designed a pan adapter for the KX2. I mean, somebody did design a third-party interface board that would allow you to use computers with the KX2. And so I guess a question for this esteemed group is, would they like a pan adapter option for the KX2? Because I could certainly think about that. And the more people out there who have KX2s, the more likely it is that that something like that might appear someday. So let me know later on if you see a consensus emerge on the question of whether let's call it a PX2 would be an interesting feature. As of right now, the KX3 has a PX3, and it's the same height and thickness as the KX3, so it's a matched set. Typically, the way people use KX2s is they're out in the field doing SOTA activations, or they're doing, picnic table operation. And usually the band segments that you're operating the radio in are not large enough to really justify the need for a broadband spectrum analyzer. That said, like Elecraft is all about cool stuff. So if we thought that a lot of our KX2 users would like to have a spectral adapter as an accessory, then we'd consider that. Now, if you purchased this third-party interface board, I believe it would also work with the existing pan adapter, the PX3, the one for the KX3. So you can explore that possibility. that would give you a pan adapter for your KX2. It's just that it wouldn't be really tiny. Obviously, now that you know what my design philosophy is, you can imagine variations on what a PX2 might look like if I were to design one myself. It would be very tiny, and it would attach to the radio directly. So I'll keep that in mind, guys. That is an excellent suggestion. Let's see, I'm going to zoom in right here and just show you that I made a mistake. You'll notice that these connector pins are not lined up with the holes in the PC board. And chances are that this is an old version of the board layout where my PC board designer got back to me and said, hey, they're offset by 20 mils. Can we go ahead and adjust the PC board? And they did, and then I didn't put their new version of their model back into my model. So iterative design is absolutely the rule with any product of this complexity. You'll notice that the LCD has multiple layers. I was able to put an actual photograph of the LCD directly into this model. That's why you can see the segments. And then we have the reflector and the glass and the backlight. And an interesting feature of the KX2 is that this design is so dense that some of the parts on the top circuit board are actually very high reliability passive parts like capacitors and resistors, and they are actually underneath the backlight. We had our LCD manufacturer design the backlight so that we've got this nice big hole here underneath. And so we were able to put lots of resistors and capacitors in there, extremely low failure rate items, so that it wouldn't matter that the LCD itself is now soldered into place. So that's the kind of trick that you have to pull if what you're trying to do is maximize the density of a radio. And this is about as dense as it gets. And that's also why the KX2 is not offered as a kit. We felt that the size of the parts and the hardware were all just too small for reliable kit assembly by people with a wide range of kit experience. So let's see, I'm going to add in the last of the circuit boards here. This is the KXIO2 circuit board. As you can see, it just plugs into the RF board and is nestled up there against the left side panel. And in fact, here is a jack that's mounted on the KXIO2 board. And you can see how tight the relationship is between this plug for the ground wire, this jack for the external power supply, and this little jack, which is mounted on an isthmus of FR4 glass epoxy circuit board material. I just noticed that it's a tiny bit after 10. Doug, do you have a question out there for me by any chance?
I have some KX3 questions and a couple of battery inquiries on the KX3 as well. But the
Okay.
KX2 guys are enjoying their coffee, it seems.
Okay, or I've mesmerized them. That's possible.
Indeed.
You want to throw out a KX3 question? I'll go ahead and take a crack at it.
Absolutely. Matt Sendas asks, a KX3 question, is it possible to get a volume function in the DSP to be able to lower AF gain when working split? SM0FPR.
So what this is referring to is the fact that the KX2 and the KX3 both have dual watch. They allow you to listen to both receivers at the same time. And that's a feature that you won't find on any other small radio. So you can be listening to one frequency where you're operating, let's say, and then you can be tuning the band with the other VFO and listening around for the next signal you're going to call. And the reason why we included that feature is that sometimes when you're doing hunt and pounce operation, like in field day or a contest with QRP, you might be parked on one frequency for quite a while trying to work one station while you are then still looking around for the next guy you're going to call. And then when you find that next guy, you just hit the AB swap button and now you're on his frequency. It would be nice, excuse me, to be able to separately control the VFO-A and VFO-B volume. That's a great idea. And Doug, would you mind taking a note for me on that? And I'll get that into the wish list on Monday.
Yes, boss.
Okay. I want to show you one other feature here in the 3D model. This is the plug for the lithium-ion battery pack. And we could have just left it at that, where the plug itself is the strain relief for the wires. But what we discovered when we built the first prototype KX2 is that it's when you're reaching your fingers down inside the radio to try and unplug this, you have a tendency to grab the wires. So what we did was we designed a little nylon strap. That's this guy. You notice it's slightly translucent. I don't know why, but I kind of like stuff that's translucent or transparent, as you remember from the keyer pedal. So this little strap attaches to the wires before it's assembled onto the battery. Then you put the connector on, and then if you see, I'm gonna turn off the circuit boards so you can see this better. So this is the plug for the battery. And so now when you want to extract the battery from the radio, instead of tugging on the wires, you grab this little nylon strap, and you have no chance of damaging the wires or the plug when you extract it in that method. So that's just one of many little touches that you discover when you're prototyping. Okay, so we've put together most of the radio here. Let's go ahead and add on just a couple of more items that are really important. 3 things here. Some of you who have a KX2 already may not have noticed this. I'm going to go ahead and put the rest of the panels on. But okay, so I'm going to go back to monochrome face style. So you'll notice that there's these 2 little screws here. Those are PEM nuts, and they're threaded 440 locations, and those are for mounting a clipboard to the back of the radio. So some of our SOTA operators mount a clipboard or a keyer paddle or both onto their own little piece of material, and then they can screw it to the right to the back of the radio. This is the kind of touch that's the reason why the KX2 is so popular among SOTA operators, is it has all of these things built in that they need to make their operation efficient. Now I'm going to go ahead and add in the feet. So you'll notice we have 3 little round feet, and again, these are about the smallest rubber feet in existence. We attach them with number 2 screws, and you'll see that they provide a 3-point mounting surface that still is just slightly higher than the speaker bump out. And so a 3-point mount is really important for a portable radio, because you might be operating on a surface that's not flat. And I'll give you a really good example of that in a second. The other thing to notice about the bottom cover is I'm going to add in this tilt foot. So we have a tilt foot that has its own thumb screw. And again, you can use that as a ground point, mounting point if you want to. And so right now you see the tilt foot is actually deployed, but it folds up when you're not using it. So here's what the tilt foot looks like when it's stored. And that's the reason for this bend in the metal. You then tighten it down, and then it doesn't flop around in transit. And then this is a little rubber foot, because we don't want to scratch anybody's table. So we have rubber for all the contact points. All right, now I want to show you why you really want to have 3 contact points. And this is also a way of highlighting just how comprehensive the SketchUp model library is. So let's go back to shading with textures, and I'm now going to put a rock into the model. This rock, which came for free with the SketchUp model library. And by the way, I use the Pro version of SketchUp, and the reason for that is that I have to export some segments of my model to other mechanical designers who work with our vendors to then get the fabrications made. So the Pro SketchUp will export to all kinds of different formats for files, including direct 3D print file formats. Okay, so here you see a KX2 sitting on a rock. And the reason the rock is transparent is it allowed me to really move the radio around the rock and get an idea of just how effective our 3D point mounting technique would be. And turns out to work really well. In fact, you can even use the bipod and the whip on a rock, because the bipod, which now you see right here, is violating Mother Nature by showing the bipod falling down inside the rock. I'm not strong enough to do that. So anybody who can extract it from the rock gets a free bipod, kind of like the sword. Anyway, the bipod is adjustable. So you loosen up the thumb screw here, and then you can adjust the legs on the bipod to match the surface. And so I'm going to now stop my screen sharing and go back live here so that I can show you the bipod. So here is the Elecraft whip bipod, and the whip antenna itself snaps into the bipod like so. Oh, sorry, the B and C end. Okay, so a nice firm snap there, and now the whip is snapped into the plastic piece for the bipod, and that then attaches to the radio, and you can adjust the feet. Okay, so that's the end of the 3D modeling part of the program here, and maybe a good time to just check to see if there are other questions, and then I'll move on to the next portion. Doug?
Yep, the KXPD2 versus the KXPD3. What are the differences?
So the KXPD2 is about half the size overall of the KXPD3, and by now you know that the philosophy is to shrink the KX2 as much as possible. So the KXPD2 is much smaller, it's lighter, and it is one of the many accessories that will fit into a very small bag. So that's the basic difference. The KXPD2 also has a place to store the Allen wrench if you need to do adjustment in the field. That's an advantage of the KXPD2. KXPD3 is machined out of, the entire thing is custom machined out of aluminum block. And so the KXPD3 has a bit more of a traditional metal keyer assembly feel. And so some people prefer the KXPD3. Either one of the paddles can be used with either of our radios. They will both plug into the same place. But if your goal is ultralight operation, then I'd suggest going with KXPD2.
Thank you kindly. Interesting applications with solar panels, but the batteries must be removed from the KX2 in order to be charged, regardless of the recharging source. True?
That is absolutely correct. And if you've been paying attention to recent developments, we're not the only manufacturer that has their batteries that are plug-in and not inside the radio when they're charging. And the reason for that is that if you think about the history of lithium-ion batteries in recent years, there has always been concern about lithium-ion batteries getting too hot, possibly outgassing, possibly damaging the equipment that they're in. Now, we've never had, as far as I know, out of thousands of KXBT2 battery packs shipped, as far as I know, we've never had one that melted down or caused any sort of problem. But that said, when we did the design, we were proceeding out of an abundance of caution. We did not want to attempt to charge a lithium-ion battery inside the radio. You'll notice that lots of other products, including iPhones and cell phones and laptop computers over the past 5 years have been recalled because they caused injury or death due to their lithium-ion batteries melting down. So we felt like it was more important for our customers to have the safety factor of not charging the battery internally. We've had such a good safety record with the KXBT2s at this point that in the future we might consider an onboard charger. It seems to me now in hindsight, after 4 years of experimentation with these lithium-ion battery packs, that have a lot of built-in protection, the way they were custom designed for Elecraft, that we might very well be able to offer an internal charger in the future. But as of right now, the KX2 is a very, very safe product to use because there's no charger internally. It's also not hard to unplug the battery. It takes like literally maybe 5 or 10 seconds to take the back cover off with the 2 thumb screws and unplug the battery pack and then swap in another one. If you had a built-in charger, of course, you would have to charge the battery before you could use it. So the KX2's battery technique allows you to instantly swap in a different battery, and you can instantly plug in a second battery pack externally because of the two identical DC barrel connectors. So I hope that answered the question. If not, feel free to post a follow-up one. Other questions, Doug?
As we're approaching 10:15, 15 minutes more in the conference, any questions that don't get addressed, feel free to contact us as a follow-up to this email address, support@elecraft.com, support@elecraft.com. One of our customers points out that interesting chemistries of batteries are coming about, no longer limited to only lithium ion. Lithium ferrite potassium, probably? I'll sound it out and say LifePo is one of the examples. We have had many customers operating with different manufacturers of batteries. And so long as it is a recognizable name, someone that you could file a warranty claim against if your radio was damaged, those are our general guidelines. Lots of great battery manufacturers in the world. Some are clunkers, but generally you can smell them at a distance.
Yeah, that's true. There are multiple new battery chemistries out there. The A123 batteries are very stable. Those were, in some cases, kind of experimental or not really well proven when we started thinking about the KX3 and KX2 designs. That's why the KX3, for example, has a place for 8 AA cells. And the intent was that it be used with lithium camera batteries, which give you 12 volts from 8 of those batteries. And you can actually get 5 watts from internal battery on the KX3. On the KX2, we wanted a really large amount of energy and power density, and that's why we went with lithium ion. If we ever redesigned a KX3, of course, we would consider using the same lithium ion battery pack in that as well. There's not room in the KX3 for this battery pack as it is. But yeah, multiple different battery chemistries on the market. Another really exciting thing coming down the pike is graphene. So some of you may be familiar with graphene for its use in electrodes in lithium ion batteries. Graphene can also be used to make something called ultracapacitors or supercapacitors. And these have exceptionally high volumetric density of capacitance. I once heard it said that a pea-sized, meaning like a 1/4 inch diameter piece of solid graphene, if it were spread out into a single layer, a single atomic layer, which is what graphene does, would cover a football field, a pea-sized piece of it. Doug?
I'm here.
We just got signed out. Did you notice that?
I still see 66 participants. Just in case, welcome aboard, guys. Would any of you like to interact by raising your hand? Yep, 1 raised hand, 3, 5. Many people are still with us.
Yeah, okay, great. All right, so I thought we'd lost them. Let me go ahead now and turn on a second camera here, and we'll do a little bit of, let me see if I can share my iPhone screen. And Doug, just break in if you're seeing any issues with that. I will go ahead and share the iPhone screen here now.
Wayne, can we do extended sideband on the KX2?
Yes. Actually, let me just double check that in the menu. So I'm using can you see my KX2?
And it's well oriented.
Okay, I'm going to go into the menu here. And I believe that, okay, so the answer to the question is you can do extended sideband mode on a KX3, but not on the KX2. That is not in the design of the KX2. However, the KX2's receive bandwidth can be adjusted quite wide, and the transmit bandwidth, I believe, is 3,000 kilohertz. So not quite ESSB, but generally when you're using a portable radio in the field, you're really after punch. You're not after a kind of sonorous, AM broadcast band quality audio. For that, you'll want one of our desktop radios or a KX3. All right, I'm going to turn on a KX3 that I have sitting over here on the side. And
the crowd goes wild waiting for the KX3.
yes. So I'm going to just set this KX3 up, so stand by, and I'll show it to you in a second. I'm going to put both, so you'll notice that the KX2 is in data mode. You can see from the right-hand side there it says data. And it's in FSK mode, and one clue about that is that you can see the segments popping around on the CWT scale, and you can also see that the DSP bar graphic right here is showing you that we've got mark and space filters going. So right now it's decoding just noise at that frequency. So I'm going to go ahead and switch to 20 meters on both my KX3, and I'm going to put the KX2 on the same frequency. And now I'm going to send a message in FSK from my KX3, and you'll notice that the KX2 is now decoding the RTTY from the KX3. And in fact, I have no antenna connected to the KX3, so it's not really putting out enough power. I don't have any antenna connected to the KX2 either. So let me just go ahead and put an antenna on the KX3 so it's got a bit stronger signal. And there we go. We now have solid copy on the KX2, even though it has no antenna, and that's because I've got an antenna in the near field of the KX2 that's clearly picking up the KX3 without any problem. KX3 is actually sending a signal on auto repeat too. Now I can interrupt the KX3's transmission, and I'm just sending with the keyer paddle. So one really unique feature of both the KX2 and KX3, which is also in the KX or in the K3 and the K4, is that if you are in either FSK mode or PSK3163 mode, then when you send CW with the keyer paddle, it converts it to data mode and transmits it as data. But you still hear the side tone from your own radio. So it means that you can do data mode communications without even using a computer. And that's one of the reasons why I love FSK mode. It's very easy to tune signals in on the radio, and it's very easy to then use the keyer paddle, or you can use our KX2 or KX3 utility and transmit with the keyboard. All right, and just quickly here, I'm going to move my camera over and show you the KX3. So the KX3 is really the way to think of a KX3 is it's a K3 that's about like 1/6 the size. The K3, it's a 10-watt K3 with an attached keyer paddle, and it actually has narrow passband or narrow filters as an option. It's an SDR like the KX2 and the K4, but it has nearly all the same features as the K3, and you'll recognize a lot of the same controls. So right now the KX3 is also sitting here demodulating FSK, but it will do all modes, and it covers 160 through 6 meters, and it also has a 2-meter option. So I don't have the 2-meter module hooked up to an antenna right now, but it has its own antenna, and you can get on 2 meters with somewhere between 2 and 3 watts, which in the field is fine for like checking in with most repeaters. And it's also, of course, an all-mode 2-meter module, so it can be used as a in CW mode or for weak signal work. And then the other part of this is the PX3 pan adapter. It's full color. I don't have any live signals on it right now. I've got some simulated signals, but you can adjust the waterfall height to wherever you want it, and you can also do text decode. If you turn on the text labels, I don't have that. Oh, here we. Yeah, there's a way. It's not set up right now, but you can have the text decode that's on the KX3 itself be piped into the PX3, and then instead of the small VFOB display for decode, you get 3 lines of text transmit and receive on the PX3 itself. And the other accessory that we have that works with both the KX2 and the KX3 is our KXPA 100 amplifier. And I'll just give you a quick look at that. This is a KXPA 100. It's kind of like the size of a small shoebox. It's all heat sink. There's no fans. It's great for mobile or for home use. And as you can see, we got bar graphs on the front of it. So there is your amplifier, and the amplifier is completely integrated with the radios. All right, okay, Doug, I think we may be out of time.
We're down to the last 4 minutes. Madeline just gave me a nudge. Thanks for noticing.
Okay, so I'll take any additional questions at the end here, if we have any.
Regarding frequency memory settings on the KX3,
Mm-hmm.
any particular software recommendations?
Yes, so you can set up your frequency memories inside the KX3, of course, manually. That's all of our radios have a full user interface for setting up the memories, but we also have a program called K3 Memory, which is multi-platform, and you can use that to get nice big screen presentation, spreadsheet format to configure your frequency memories in a much more convenient way. You can preset them. In fact, I believe the K3 memory program comes with a number of frequency memories already set up, such as the channelized frequencies for 60 meters. So I would use K3 memory for doing that. I greatly appreciate Doug's help as my virtual Ed McMahon.
It's a pleasure.
And, yeah, good job, Doug, and thanks for the help. To everybody, again, thank you so much for attending.